Okay, we're going to carry on with acylation. We're going to address a certain sort of question which is quite often asked. And this is like writing equations, okay, for writing equations for these acylation reactions. Okay. Now, I'll start off with a fairly simple one. That wouldn't probably be asked because it'd be too simple. Let's say the question will say something like, complete the equation. Right, so we've got, and it will write it down like that. Now that's ethanoic acid, isn't it? But it always writes it down in the one line form of the equation, which can be confusing. And that's going to react with ethanol. Now, we could probably do that one in our head because it's pretty simple, but just to show you how the way I'd approach these is when formulae are written in one line, it is confusing. It's better to show them as displayed or semi-displayed. So I'd write that down like this. First of all, there's a bit of working out. We cross this out. And then ethanol. Now, which bit of the ethanol molecule is it reacts with the carboxylic acid? Well, it's the OH group, isn't it? So it makes sense to sort of draw that backwards. And then we won't draw every single carbon, every single hydrogen, because that's a bit over the top. But now we can see what's going to happen there is the first step in the mechanism, isn't it? Well, the lone pair on the oxygen is going to go to there. Yeah, I'll get rid of that. And we're going to eliminate a water molecule. So the product we are going to write is writing it out semi-displayed, and the small molecule which is made is water. Okay. Now you shouldn't really write out you shouldn't really write it out like that. You should write it out. So I'm going to write it down at the top. So you would, how would you write this formula down? You write down CH3, to write it all on one line, COO, CH2, CH3, and H2O. So I think it's really important to do this blue line of working out before you jump to doing just writing in the products there, because if you do that with a simple example like this, yeah, you'd probably get it right. But with more complicated ones, people always get it wrong. And the reason why I'm making this video is because when Mark ended topic tests and mock exams, people always get these questions wrong. Like half the class will get it wrong, 3/4 of the class will get it wrong, and it's not very difficult. But you just got to take things a bit, you've got to include your working out. And say another thing here, you shouldn't write. They don't like in the mark scheme sometimes it says don't accept things like. So how would you write? Ethanoic acid? Some people might write down C2. H4O2 plus C2H6O, and then you write that as C4H8O2. They don't like that, okay? They don't like formulas written like this. You just write the molecular formula. It's not meaningful. It doesn't show any of the functional groups in the molecule, so don't do that. You want it in that form. Okay, not the displayed form or the semi-displayed form, not just the molecular formula form. You want it as this black line. That's the one that you want. Okay, so let's do a bit more of a complicated one. Not that much more complicated, but you can pause the video and then you see if you get the right answer. So let's say we've got next example. You've got CH3COCl plus okay, so what is this stuff? CH3COCl. It looks a bit funny written down like that, and so it is That makes more sense to me. Anyway, if this semi-displayed, it's an acyl chloride, and it's going to react with the alcohol group there, isn't it? So it makes sense to draw this. This is propan-1-ol, isn't it? But let's draw that backwards. We're going to eliminate the HCl there, aren't we? So we're going to get CH3, C, O, CH2, CH2, CH3, and the small molecule we're going to get is HCl. And if you leave the small molecule out of the equation, obviously it's not a complete equation, and you'll lose the mark, and it's usually only like 1 mark, so you can't make any mistakes, you just lose all the marks. Right, so let's write that down in black. As on a one-line formula, you'd write down CH3, COO, CH2, CH2, CH3, and HCl. That's all done. Okay, that's the second example. Okay, let's do one which is a little bit more complicated than either of those two now. Okay, so all right, so we've got this stuff, CH3CO, and now this is definitely much more confusing, and quite often people don't realize even what this is. What is this funny thing? Well, it's an acid anhydride, isn't it? So we've got a CH3C double bond O, then we've got this O there, and then we've got the second of those CH3O groups here. Okay, so that's what we've got there, and we're going to react that with the amine. Now, which bit of the amine is going to react? Well, it's the lone pair on that nitrogen is going to attack this carbon here, isn't it? So let's turn the amine round, propylamine, so that it's the right way round. Makes it easier. So we've got okay, and we are going to lose that there. So we're going to eliminate the carboxylic acid. So we'll get CH3. We've got the carbonyl group there. We've got the NH. Okay, so and then we have carboxylic acid. Don't forget the carboxylic acid, otherwise you won't get any of the marks. By the way, what is this stuff called? Well, if you like, this is ethanamide, isn't it? Except one of the H is being replaced by this group, which is a propyl group. So it's N-propyl ethanamide. Okay, let's draw that in the one line form of the equation. So it's going to be, move that over a bit. You're going to get CH3, CO, NH, CH2, CH2, CH3, and CH3COOH. Now, you may think, oh, well, I could have done that without drawing all this blue stuff here, but as I say, when you're marking them, nearly everyone gets these wrong, you know. So it just take a couple of minutes. Don't try and do this stuff in your head, okay? Okay, don't try and draw the blue bit in your head and then just expect to be able to get the right answer. You probably will make mistakes. Okay, so we'll do one more example of this. Again, this is going to be a bit harder than the last one, but similar. So see, we won't have any problem in recognizing what that is this time. It's obviously the acyl chloride, and we're going to react it with okay. So let's write down in blue. What we're going to have here is we've got CH3, the acyl, the acid anhydride. Now, which bit of this? Now, what have we got here? We have got, it's a secondary alcohol. It's propan-2-ol, isn't it? And it's the lone pair on that oxygen which is going to react. I'm probably going to draw it like this. CH3. Here's the alcohol which is going to react with that. And that lone pair is going to attack this delta positive carbon here, and we're going to lose that bit, aren't we? And we're going to lose the H, and that's going to, those two are going to form the carboxylic acid. So let's draw what that looks like. So we can have CH3, C double bond O, and then we're going to have this carbon, okay? So that's going to be O, CH3, H, CH3. And the small molecule is going to be ethanoic acid again. Okay, so now we need to convert that blue form into the black single line, which is tricky. So CH3, CO, and this O. Then we want this carbon. What's attached to this carbon? We've got two methyl groups, haven't we? And an H. So that's going to be CH, CH3. And how many of those CH3? There's two of them. So a little 2 there. And then we want that. By the way, they don't usually ask you to, they occasionally do, not very often ask you to name what an ester would be formed when it's formed from a secondary alcohol. What would this ester be called? And it is a bit tricky. Well, you have to call it, right, methyl. And then what is this? This is basically like an ethyl group, isn't it? And this is the oic acid bit. So it's methyl, ethyl, ethanoate. Okay, so that's the end of that one.